Center for Bright Beams is a National Science Foundation Science and Technology Center. We get a large group of people together to work around one big idea. And in our case, the big idea is increasing the brightness of electron beams. It turns out the world's brightest beams are made by the photoelectric effect. So one of the things we're trying to do is understand photoemission. How does it really work? How can we design a photocathode that gives the brightest possible beam? Then we look at the place where the beam is accelerated to light speed, and we're looking at new technologies that will enable the use of very high power beams in normal settings, not just at a national lab or a very large facility, but really made accessible. Finally, we're looking at how do you transport those beams. Beams can start really bright and wonderful and then deteriorate as they travel. The Center for Bright Beams has brought together this very dynamic group that is pooling their expertise in order to increase the brightness of electron beams.
We are a surface chemistry or surface science group. We're physical chemists, and right now we are looking at some of the fundamental behavior driving the growth processes of niobium-3 tin. As a surface scientist, as a chemist, I was not particularly aware of the exciting research and development that goes on to make these very complex, large facilities, or even electron microscopes that you use in the lab or in industry, in medicine. And it's been fascinating to learn about this world that I was unfamiliar with, and then understand how I, as a chemist, can fit in with it and bring a specific knowledge base that is useful and different to the equation.
We have two ways of improving photocathodes. The first thing we are studying is trying to make them flatter and more homogeneous, because flatter and more homogeneous photocathode will have the lowest emittance the material can possibly give. And the other thing we are studying is new photocathodes, new material that can produce more collimated electron beams. It is very important for me to exchange ideas, and sometimes it's true that if I look too much at the same problem, I don't find solution, but maybe there is someone else who took a class in a different university and comes from a different field and say, oh, but we already solved this problem, or can tell me, oh, this problem you are dealing with is very difficult, but I can help you out.
It's been fabulous to see this group, all different kinds of experts who frankly had never really spoken to each other before, certainly not gathered around a particular project. And now there are dialogues that happen that never could have happened before and are incredibly exciting and productive.